Hi, all. Welcome to the Disaster Response and Robotics demo session. My name's Alexa Miller. I'm here on the Chamber Foundation team helping to put on the larger PPP conference, but really where my world of work lies is in tech for good. So this session today is brought to you by Digital Empowers. It's a program that I lead that is also co-led with Tata Consultancy Services that really focuses on celebrating technology and the positive impact that it has on our world. So in theme with PPP, we're talking about the future of collaboration and leveraging intelligent systems, robotics to combat the spread of the virus and protect, our essential workers and nurses, keeping us in business, from the beginning of the pandemic, potentially for the rest of time. So I will turn it over to our speakers here in just a minute, but they all wear many hats: roboticists, engineers, academics, entrepreneurs, all rock stars in the tech industry. First, you'll be hearing from Diligent Robotics, Andrea Tomas, Zimmer UVC Innovations, Elliot Kreitenberg, Optimus Rides, Ryan Chin, University of Illinois at Urbana-Champaign, Chris Hauser, and Skyscope's Matt Dunlevy. And then before we get going, I just want to walk you through the flow. So speakers will be broken up into two groups for these demo sessions. We'll do two back-to-back groups, or I guess two back-to-back presenters, followed by a Q&A for those two presenters. And then the second set of demos will present, and then they'll have their combined Q&A segment. All of you guys viewing will be muted, but you can submit your questions through the chat function, and I encourage you to do so kind of throughout, because we want to be ready when we get to that 5-minute portion, at the tail end of the first two and then last three presenters. So without further ado, I will kick it over to Andrea.
Thanks, Alexa. It's great to be here today and be able to present to this great audience. I'm really excited about the session. My name is Andrea Tomas. I am CEO and co-founder of Diligent Robotics, and I'm going to share my screen here and give you a little intro to Diligent and demo. Here we go. Am I sharing the right screen?
Yes.
Great. So Diligent Robotics, we are building mobile manipulation robots that are really designed for the future of work. So where we have, we're wanting to put people side by side with robots. And our first product is Moxie here, designed to help hospitals deliver consistent, high quality care, and specifically taking on some of the just logistical and support tasks that often fall on the plate of healthcare workers and nurses. So we founded the company 2 years ago and are built on kind of years of experience of building robots for human environments. But the specific problem that we're helping hospitals solve today is a kind of the workforce challenges that they have. And even before this pandemic, hospitals were getting to kind of crisis mode in terms of, shortages of their nursing staff and healthcare workers. And now more than ever, those frontline staff are really, being really burdened, and they're being stretched really thin. And so what we hear from hospital leadership all the time is, we're really looking for ways to do more with less, and to give our staff time to function at the top of their license. And that's really what we're about, is giving hospitals and hospital staff the tools to help them, elevate their staff and leverage their staff even better. So I'll just flip straight to a video here where I can show what our product is out in market today doing. We've got a couple of customers in Dallas that are first users of Moxie. And what we're doing in Dallas is staff requested deliveries with access controlled locking storage. So any member of the staff can kind of request a robot to come autonomously drive through the hospital to different locations. Then they can use their badge to unlock different kind of storage compartments. And this is configurable. We also have like a really large drawer if that's more of what's needed in the environment. And then they send the robot on its way to the destination, and the robot heads off. That we'll see in a second. One of the ways that manipulation really becomes useful in the environment is letting the robot take advantage of some of the handicap buttons and badge swiping devices that allow it to kind of autonomously make its way through the hospital. We have the ability to kind of remotely supervise and see what the robot's doing and kind of monitor that remotely, so we can help the hospital kind of have that data to really get their understanding of what the robot's doing at any point in time. And what we've seen, so this is kind of shows you the general capability of the robot, and what we've seen in the last 2 to 3 months with our customers is just increased utilization around as hospitals are really working to have essential personnel in the hospital only, and they're really looking to mitigate risks to hospital workers and staff. So we're seeing that there's a lot of desire to reduce the number of people that are running around the hospital. But the biggest items that we're transporting around are PPE deliveries. So the supervising house supervisor nurse is doing a lot of deliveries of PPE in very targeted fashion, since they know they want to kind of have that PPE delivered around the hospital in kind of a just-in-time use capacity. So we're doing a lot of PPE delivery and a lot of deliveries around of COVID test kits and COVID test samples. So right now, any COVID sample is, the protocol is to hand carry it to the lab. And so instead of having a nurse that has to hand carry those samples, our hospital customers are making use of Moxie to do that for every day. So we're seeing a lot of ways that the hospital staff are getting really creative about how they can offload some of these more logistics and operational tasks and keep their staff focused on the things that matter. And what really we think this is all about is letting hospitals kind of change the clinical skill mix of their teams. And so you have like the things that people are good at, and they're specialists, and they are focused on patient care, whereas the things that robots can be good at are functioning kind of hospital wide and being that data driven, reliable piece of the puzzle. So I think I'll stop there and hand over.
Elliot.
Yep.
Elliot. Yeah,
Very
thanks.
cool.
Great. One moment. We can all see my screen now. All right. Hi. Good morning, everyone, or good afternoon. I'm on the West Coast, so still mid-morning here. I'm Elliot Kreitenberg. I'm the co-founder and president at Dimer UVC Innovations. Leaders in UVC innovation since 2012, and you may be familiar with our Germ Falcon product, which is a UVC disinfecting machine intended specifically for aircraft interiors. About a month ago, we signed a strategic partnership agreement with Honeywell to bring our aircraft interiors product line to market, and our IP and our product line extends far beyond the aircraft interior. Today, we've seen a newfound demand for products like ours as we try to spark this COVID economic recovery. As a country, we are looking for ways to get employees back into buildings and customers back into stores, and people living their lives as normally as they once did. And companies are looking for any options that may help accelerate that process. What everybody is considering now is a comprehensive program to address hygiene and infection prevention moving forward long-term, permanent new standards. And we think that UVC disinfection and surface disinfection specifically is a really important part of all that. of course, I certainly hope that people will be taking their personal hygiene and hand washing more seriously moving forward. We may see temperature checks as we go in and out of buildings, but I don't think anybody sees social distancing as, you know, a long-term solution. Hopefully in the post-COVID era. When we're talking about surface disinfection, we know that surfaces contribute to the way diseases spread from person to person. Inanimate objects that spread disease are called fomites, and generally high-touch surfaces are the most contaminated surfaces. And there are only a few options for how to disinfect these surfaces. You know, chemical disinfectant solutions, which work well, but if you read the fine print, they take a long time. Traditional UVC options have limitations because they're corded and stationary in a room, and distance and angle are really crucially important to disinfecting effectively. Foggers have become increasingly more popular since the beginning of the COVID pandemic. And my co-founder, my company's background, our roots are in healthcare. My co-founder is a surgeon, and the general healthcare opinion of fogging systems is, wouldn't that be nice? We are offering UV solutions that are mobile. You have the ability to articulate the angle of the lamps, and new research in the last couple of weeks has come out showing that there's a 5 millijoule per centimeter squared dosage required to kill COVID, and our machine is capable of delivering that in less than 1 second. So I'll jump quickly to a demo video here. So quickly, I'm going to go over how the UV hammer works. The UV hammer is basically a germ falcon for hospitals, is what it was originally designed for. But we can do meeting rooms, we can do kitchens, we can do classrooms, basically any variable environment, any variable space. This machine has the versatility to adjust its angles and all these things. So in this box, I just want to call everyone's attention to the beads. These beads change color with exposure to ultraviolet C light. And here I'm going to show how a vertical stationary system, like traditional systems that you'll see in hospitals, typically work. So you'll notice that the beads that are closest to this lamp are starting to change color already. They start to turn purple. But the further away you go, the only way to overcome these distances is by increasing time. So after 2 minutes, we really haven't gotten very far down the row. You'll notice that these shadowed areas really haven't gotten any exposure because they don't have this direct line of sight that's crucially important when you're using UVC. From another angle here, the stationary lamp over here, we can get these ones. We're not getting very far down the row, and the ones in the hidden areas are never getting exposure. The way the UV hammer works is we overcome these distance and angle issues, and we add mobility. So our lamps are always parallel to the surface we're targeting, and you're able to go surface by surface by surface around a room to quickly and effectively deliver high dosage to every surface. Again, this is the stationary vertical lamp. We're not getting in this grid area at all. We're not getting in these folds. And these are kind of simulating real world surfaces and high touch surfaces, horizontal surfaces. Horizontal surfaces have far more contamination generally than vertical surfaces because gravity forces horizontal surfaces to catch the germs, whereas vertical surfaces have a harder time with that. So as you can see, the machine kind of can attack any environment. We can overcome any texture issues, any soft, hard, porous, non-porous surfaces. Really any environment. Versatility is at the core of our machines. And we are the only company that's doing anything like this with an operator mobility, the ability to adjust the angle of your lamps and really treat any variable environment, building, public transportation, aircraft, what have you. And our products are new to market, but we have been working on these for some time, and it's clear that our research is ahead of the curve in this space. I can skip to the next one. So just quick overview. Again, we're more effective than the other systems that are available because we have this ability to adjust the angle of our lamps. We have this mobility. The competitive systems that I was talking about, the stationary systems, because they have to overcome that distance, it typically takes 40 to 60 minutes start to finish to treat a room. We're in and out of a hospital room a 400 square foot hospital room in about 3 minutes, where our competitors take close to an hour. So you notice that on our machines that we have these operator shields built into them. This prevents any exposure from the operator getting any UV dosage to skin or eyes. And the light switches are controlled by spring-loaded switches, so you let go and the lights automatically shut off. It's very simple to use, and one of the great advantages about this system is it's sustainable. There's no waste. There's no materials that need to be swapped out. There's no consumables. So again, here's just a quick overview. Some of the different spaces that we've disinfected. We've done office buildings and conference rooms, commercial kitchens and restaurants, athletic facilities and gyms. And we've started to do more complicated and creative spaces. This was a partnership we had with our friends down in San Diego with a company called Ride Circuit. And they have a lot of riders in their cars every day, and they wanted to make sure that they were providing the most hygienic environment for their passengers. Who else believes in Dimer? Like I said, we just signed a deal with Honeywell where they're going to be commercializing our aircraft interiors products. They are a very big company who is known for their due diligence and their research. And the way that they're currently presenting our system is right there on their aerospace homepage. You can check it out. It's a great product. I think it's really going to help people get back to flying, and it may have quantifiable public health benefits long term. That's the goal. And our other products basically do the same thing, just everywhere but airplanes. Just really quickly, a McKinsey consulting study that came out recently, basically customers in hotels specifically, but I think it translates across many different industries, are really interested in more intense room cleaning as something that will make them feel comfortable going back to the businesses that they patronized in 2019. And UV light specifically is something that people want to see as a new hygiene protocol, or a new part of the protocol. So that's just a quick overview on Dimer. Leaders since 2012. Let's save the world.
Okay, great. So now Q&A for both Andrea and Elliot. So first, there are a few dual part questions that have come in. So let me first start off with, are there any challenges or hindrances to using this technology from your perspective as the business lead in getting to market, and from the potential client or consumer's perspective?
Is that for me?
Both.
Go for it, Elliot.
Okay, so UVC is relatively new to a lot of people. It's a little abstract to think light can kill germs. Hospitals have been using it for a long time. I think that's one of our biggest barriers to entry is overcoming this education about UVC. There are a lot of products out there. And I think that a lot of people have heard that it works and it works well, but it works well when it's used properly. And I think that's one of our biggest challenges right now. And being a new company, a few months ago, it was my father and I in the garage, and now we're a bit bigger than that. So hopefully that makes it easier for our customers to start to incorporate our technology.
Yeah, I can take that one too. So same kind of thread there. I think, whenever you're trying to introduce something new to a hospital, it's going to be challenging. And what we're seeing right now in the pandemic, there's this, kind of desire to do anything to fix problems, but also, really lack of attention to think about new things. And so, for us, we've been really focused on process and implementation, making that really fast, and helping hospitals understand, like, a lot. I think pre-pandemic it would have been like, oh, let's bring you in and try it out and see, but that is just not where any hospital is at right now. So we're doing a lot to get people to understand, remotely and through demonstrations, how easy it's going to be to stand up an implementation and how quickly they're going to be able to start seeing results.
So as a follow-up to that, is there any special training involved in operating either of the two pieces?
So for our systems, we have a half-day training course. It's 90% focused on safety. Our machines are very easy to use. But yes, there is training and there's operator certification that is required for each new operator.
For us, there is some training involved. We tend to make use of champions within each nursing department, and kind of the word of it spreads a little bit by word of mouth. But we'll have education sessions at the nursing huddles.
Okay, perfect. So follow-up question from the audience. Elliot, you've elaborated about how this technology can be used in classrooms, airplanes, etc. For Andrea, is this solution as effective in non-hospital treatment settings like PT, long-term care?
Yeah, great question. We are, certainly focused on how technology like Moxie could be used in a lot of different settings. Right now, we're pretty laser focused as a small company on a single market. So we're looking at really the acute care hospital setting. But certainly there is future potential in a lot of different spaces.
And I think this is another question for both of you guys. How can smaller actors in the private and public sectors kind of build partnerships with larger corporations, hospital systems? And kind of what was that experience like for you guys? I mean, it all had to happen like fairly quickly, at least in kind of the immediate past.
Yeah, I'm not sure what Andrea would say about that, but my answer is, I mean, Dimer has been working on products like these for a long time. Our primary target market, I mean, over the last few years has been commercial aviation and airlines. And this hadn't been a pain point for them. So I guess my recommendation was just, if we thought we had a really good solution to a problem, and all we did as we had this uphill battle generating demand was keep making the product better, keep understanding it deeper, keep understanding the technology as deeply as we possibly can. And then when this whole pandemic happened, we were fortunately ready for it, from kind of a product expertise and emergency response perspective. We had an idea of where we would go if something like this happened, and I think that has helped. Preparedness as a company has helped make it more attractive to bigger companies as they reach out to us. That would be my 2 cents.
Yeah, and I mean, for us, we've been really driven by innovative leadership in hospitals that are really looking for really novel ways that they're going to kind of reinvent their workforce and their skill mix and leverage their teams. And so we've been fortunate to connect with several different innovative leaders in healthcare systems and kind of start from there.
Okay, perfect. And then last question for both of you. What are things that aren't being done in kind of the robotics space, whether it's directly in your field, or what you think could be the next big thing that you would like to take your company to from the perspective of a new direction? Or if you had a crystal ball, what are some cutting edge technologies that you'd like to get involved in?
Yeah, I mean, I think we've just scratched the surface on some of the very first sorts of manipulation enabled tasks that we're doing in these spaces. So I think that for us, we're really focused on a product roadmap that kind of gradually adds more and more manipulation skills to the robot, and making the robots more and more capable. So I think that's really when we're going to kind of unlock a lot of value for our customers. So we're excited about that.
Yeah, I typically don't call our products robots. They do have some robotic kind of characteristics, but our machines right now are operator driven. Robotics is something that we're keeping our eye on and looking to in the future. Right now, as we look at robotics and disinfection and UVC disinfection, it's looking specifically at healthcare, where most of these products have competed over the last few years. One of the shortcomings I've seen with robotics is if an unmanned system can kind of navigate an operating room for the 3 minutes that it would take our operator-driven UV hammer, as soon as that 3 minutes is over, that robot is waiting for somebody to open the door for it. And so if there's not somebody waiting outside for the 3 minutes that it's working, you may as well have the person moving the machine through the room. So I'm looking forward to a robot that can open a door. And it's something we're keeping our eye on. Until then, I think that our operator driven is safer and just as effective, and far simpler to use and to build than and to deploy than an automated system. But we're keeping our eye on it, and we're excited about the future of robotics.
Okay, perfect. Thank you both. So now we'll move on to our second group of demo speakers. And Ryan, you are up first.
Ryan, I think you're muted.
Thanks. Can you hear me now? See me now? Great. Thank you so much. Ryan Chin, CEO and co-founder of Optimus Ride. We're a startup self-driving company based in Boston. Our focus has been to develop safe, efficient, and equitable mobility solutions. And certainly during the COVID time period, we've had a lot of very interesting programs for deploying technologies that can provide access to greater mobility and logistical support. We're based in the Boston area. We have been a leading developer of what we call geofenced systems for autonomous vehicles. We develop our own IP. We have over 155 folks in our company now, 100 engineers developing this technology. And we've deployed our technology in over 5 locations across the country today, where we've moved both passengers as well as goods in the pandemic. The executive team is from MIT. The five founders came out of MIT. Albert and Sartosh, our technology folks, our CTO and chief scientists, developed a lot of technology out of the Urban Challenge from 2013 and finished the Urban Challenge race. There was about 6 teams that finished that. So they lead our tech development. Ramiro Almeida, our chief strategy officer, is an expert in mass transit systems and helped to build mass transit systems throughout the world. And Jenny Larios Berlin, our chief operating officer, is an expert in shared systems. And myself, I spent about 18 years at MIT, actually overlapping with Andrea as well at the Media Lab to develop shared electric vehicles. In fact, we built in that time period a vehicle called the City Car, which is a foldable electric car with General Motors. It completely was able to sort of reinvent the automobile and to fit three cars in one parking space. It was completely robotic as well, and it could also be driven electronically. The car on the right is the MIT entry into the Urban Challenge 13 years ago. And you can see that project was almost a science fiction project that time ago. And over $500,000 worth of equipment in the trunk of that car, if you can see that. The sensors were very bulky at the time. Sensors also had range limitations, and compute systems weren't that powerful. Fast forward to today, sensors are much more reliable. The costs are there. Computers can fit into a suitcase, a small suitcase, and we've also had the AI revolution. So the idea of the company was how do we combine electric shared mobility along with self-driving. Today, self-driving vehicles are moving away from fantasy into reality, but it turns out that there's still a long road to hoe to get to fully self-driving everywhere. But there are places that self-driving vehicles can be effectively used. That includes places like hospitals and on factory floors. But there is a new market called geofenced, which is basically anything that's 25 miles per hour or less, solving what we call the first and last mile. And there's a very significant market. That would include university campuses, master plan developments, retirement communities, airports, anything that's under 25 miles per hour in a predefined area. And what we've developed is a system that allows you to do that fully autonomously, SAE level 4. So we design and build self-driving systems. And on top of that, we also develop what we call fleet monitoring. So we monitor the entire fleet. We also have remote assistance. That's important because as the vehicles become fully driverless, you want to have a human operator sort of watching over the entire system, right? Where they can call in for help or reroute as necessary to provide customer assistance. You also have the in-vehicle experience. I'll show a video of our virtual rider assistant at the end of this presentation, which shows it's sort of the voice of the vehicle. It's almost like an Alexa or Siri of a driverless vehicle that allows the users to be able to interact with the vehicle. And of course, you want to be able to call for a vehicle. As we started to deploy this technology, we started with passenger movement only and actually transitioned to providing deliveries as well. These are the markets that we've deployed to so far with a very large pipeline of customers in these areas. The current deployments and contracts that we signed are these. So we're based in Boston. We've we've treated Boston as our proving ground. It's an urban area, certainly very complex with complex weather conditions. We deployed in the Brooklyn Navy Yard back in August of last year, 2019. We're the first and only autonomous vehicle commercial program in the state of New York, and we provide tens of thousands of rides so far in the Brooklyn Navy Yard. The Haley Rise deployment in Reston is with Brookfield. Brookfield's the world's largest real estate developer. That deployment also started in August of last year. We've had about 50,000 autonomous rides, fully autonomous there. The Yards is another property of Brookfield's. It's in Washington, D.C. We signed that agreement about a month and a half ago, and we're starting with deliveries first. And that's because during the COVID period, deliveries are very important to the tenants as well as to other needy individuals. And so we've started with that. We're going to be adding passengers as COVID subsides in that location. And then finally, Paradise Valley Estates is a 60-plus life plan senior community in Fairfield, California. It's a 15-mile-per-hour gated community. And it turns out that the seniors are obviously the most vulnerable population. So when COVID started to hit there very strongly in March, we started to do autonomous delivery of meals in that site. We've delivered thousands of meals, and the seniors could no longer, the reason for that is the seniors could no longer congregate in the dining hall. And so we decided to deliver the meals directly to them. We've also done package delivery in that location. In fact, I wanted to share a quote from one of the seniors there, or one of the management there. The management said, "Thank you so much for supporting our community in this ever-changing, challenging time. Your guys were here yesterday and more than happy to help. We were very thankful for you all, and for this partnership." And this was a little thank you token that was given by one of the seniors there for us. And you can see a meal that was delivered on the lower right-hand corner of this picture. And what I'll show now is a video of our fully driverless system operating in the pandemic situation. And certainly there's an opportunity for self-driving vehicles to solve problems both post and during a pandemic. And in fact, during a pandemic, the demand for logistics has actually increased. And then in a pandemic, you also have the need for moving essential workers. And so the goal of getting to driverless is very, very important for the entire industry. So I'm going to shift and show you another video. Give me 1 second here. I'm going to shift it over to here and then play this. And this is a collaboration that we've done with Microsoft on driverless interface.
Hey, buddy. Yeah, I'm catching my ride home now. Did you wash your hands when you got home? Great. The little things make a really big difference to keep everyone healthy. Bye.
Welcome. To get us on our way, scan your ticket. If you need anything, press the support button and let us know how we can help. Now departing.
Hey, honey. Oh yeah, good call. I can stop by and pick up some more masks. Okay, great. Love you.
How can we help?
I'd like to change my destination to the health center, please.
Okay, updating trip to health center. We will arrive in approximately 3 minutes.
Sweet.
Arriving now. Please check the vehicle for all your belongings before exiting. Thank you for riding with Optimus.
Okay, thank you very much.
Great, thank you. And Chris, take it away.
All right, let me share my screen. Is this visible for everyone? Okay, great. Thanks for everyone for setting up such a wonderful set of problems for me to start talking about. My name is Chris Hauser. I'm Associate Professor of Computer Science at University of Illinois. I'm not affiliated with any company per se, so I'd like to take this opportunity as the Mad Professor to speculate a bit about the science fiction aspects of robotics and where the opportunities might lie, not just technologies that are available today, but ones that will be available years or decades in the future. So, I think we're all seeing that robotics is essentially the ultimate social distancing tool. And so in response to COVID and other kinds of outbreaks, the world looks to robots as being a technology that can really help. And so, we're not quite at the point where we're ready to deploy robots as sort of the front line against infectious diseases, but I think we can get there. And I think even if they're not on the front line, they can still be valuable assets in the rapid response toolbox, not just for dealing with the acute stages of a pandemic, but also for dealing with the kind of recovery and also getting back to work. And so for this talk, I'm not going to do too many demos, but I'm just going to be talking about many of the opportunities, both in the short term as well as in the long term. And I'd like to thank Andrea, Elliot, and Ryan for doing such a great job of really setting up the picture of where we are now. So right now, disinfection, just like Elliot mentioned, it's really difficult for cleaning staff to adhere to these best practices. And we've seen a lot of successes with these UV disinfection devices and robots to try to help address the problem of disinfection. And these are multi-use technologies that can be used in hospitals, public spaces, transit, airlines, as well as subway cars, offices, and schools. And so most of these UV disinfection robots, there are some robots, I guess unlike Dimer, Xenex and UVD, they have these robots that can be kind of joysticked into a hospital room and then turned on. But then as Elliot also mentioned, they do have to be let out of the room and somebody has to be there to open the door. And so there's a lot of short-term possibilities in terms of using robotics and advanced AI technologies to be able to address some of the challenges of disinfection. As Elliot articulated so well, occlusions are a huge problem for these UV disinfection robots. And these shadowed areas in some studies have received a small fraction of the dose of the areas that are directly lighted. And there's also problems with distance. Another problem is that they require manual pre-cleaning. So if you have a grimy environment like a subway car, you have to actually clean it first before you can even use the UV disinfection. And so there's lots of opportunities here short term. So I've been very interested in using the kind of AI and planning technologies for doing better UV coverage by moving around the environment. And if we can map the environment and then optimize where the a UV robot goes, we're able to achieve much better coverage. So we compared the optimization solver against the standard operating procedure of something like a Xenex robot, not something as, I guess, well tuned to the surfaces as the Dimer robot. But in any case, for this particular comparison, we were able to achieve a 60% reduction in time just by sliding against the walls of this room. And in a cluttered room, we're able to achieve 100% coverage of the room rather than 20% with the standard static robot. There's also opportunities for 3D, and just like Dimer, we're partnered with another company trying to investigate this opportunity, but from a more robotic perspective. Basically, that aspect of being able to move in 3D is really critical for getting those horizontal surfaces like tabletops and beds, as well as getting around crevices and so on. We're also interested in working on robotic wiping, so trying to get rid of that pre-cleaning roadblock that these other technologies have. And so we're collaborating with this startup EarthSense, and we have an SBIR, Small Business Innovation Research Grant, to try to investigate these technologies. And another area that Andrea brought up was care delivery. And so we really have a host of different technologies for care delivery. I'd like to bring up that telemedicine is a very important technology that is really starting to take off. You can now use it through Medicare. You can talk to your doctor, get diagnosis, and even get prescribed drugs without leaving your home due to advances in video conferencing technology. And the next generation of this, which actually has been established, is telepresence. So the idea is to have essentially a Skype screen on a mobile base, and a nurse or doctor can drive around a hospital and talk to patients either through the intake process or through doing the rounds in some sort of hospital ward. And as Andrea pointed out, there are many different technologies for automation, especially for delivery, but also monitoring and communication. And many companies are looking into that. And so one question is, well, what can we do for care delivery that hasn't been done, and what might be done in the next year or so? I think one really low-hanging fruit, every time I talk to a nurse and we ask what can our robot do to help you, is that they ask, well, could you help us with these alarms? Being a nurse means that you're constantly bombarded with alarms just throughout the day. And a large part of your job is just to walk into a room and, well, sometimes you inspect to see if something is wrong. Most of the time, nothing is wrong, and you just press a button to turn off the alarm. And this is a waste of nurse effort, but it's also a huge waste of PPE during outbreak scenarios. And we can imagine having a very simple robot, such as this one. We worked on this 2 years ago. It was published in 2018. A very simple robot that could use computer vision and automated path planning to be able to select different buttons in the environment and operate them. And they can actually with a very simple device, you can not only just operate push buttons, but also switches, rockers, dials, and we're able to actually achieve 95% activation of buttons, only missing out on some very complex buttons that require a lot of strength to operate. So I think this is really low-hanging fruit, and we could probably help out a lot of nurses' sanity. Now, if we were to kind of take this to the next level, what do we really want to do? We really want to remove the person's body from the equation, right? And so we've been looking at the use of telerobotics, which is actually providing not just that telepresence and navigation, but also the ability to act in the remote environment. This work started in 2015 in response to the pandemic going on then, which was Ebola. And so we built this robot called Trina, or Telerobotic Intelligent Nursing Assistant. And it has not just the Skype screen, but also has 2 arms and grippers. And so you can operate sort of like your own body. It's basically a surrogate for your own body. And nurses can deliver food, medicine. They can also do cleaning jobs, like take off the sheets from a bed and dispose of various items. And they can also be used to do some diagnosis, some basic diagnosis tasks. Now, this requires quite a bit of training, actually, and this was probably one of the limiting steps. Although we can achieve many of the same tasks that a human nurse would want to do during their normal rounds, it takes a lot more time. And you have to be really, really highly trained to be able to kind of replace your experience with your own body with the experience of operating a robot body. Now, I'm really excited to see that actually this kind of idea of building these robotic surrogates is actually being explored by other people. And so the X Prize Foundation has launched a competition called the ANA Avatar X Prize. And I'm just going to let this video play for a minute to give you what.
We had internet, we had iPhones, now we'll have avatars.
The ANA Avatar X Prize is a $10 million competition that challenges teams to develop a physical robotic avatar system that can transport your senses, actions, and presence to a remote location in real time and feel as if you're actually there.
We'll be able to completely break through all of the barriers of distance, time, cultures that exist in our world. I think that will allow us to unleash the full potential of humanity for the very first time.
We are at the exact right time to bring different technologies together to make something that the first roboticists didn't think about, this human-to-human connection.
To connect with loved ones, maybe that you're not able to see often, to be able to transport skills. So doctors and teachers are able to use their expertise anywhere in the world instantaneously. You may be able to go into space or go into a disaster relief situation where you can send an avatar and not risk human life.
Okay, I'll stop it there. So I'm very excited to be part of a team for this ANA Avatar X Prize competition. As you can see, it's a very challenging and very sci-fi kind of concept of basically stepping into your robotic body. We're building a next generation of our Trina system. We're calling it AvaTrina. This is a joint work between Illinois, Duke University, and a startup company, V-Rotors. And we're trying to provide not just a great robot, but also a great experience. So this robot that we have is slimmer than the previous version, more dexterous and more precise, and also stronger. We're also working a lot with V-Rotors to build a virtual reality kind of system where you can see what the robot sees, hear what it hears, and also touch what it touches. And so my team of students working on this robot is shown up here, and we're working mostly on the kind of AI component and also the hardware component of this work. But we hope to see that in the future with this with continued development and sponsorship, that we'll be able to do well in this competition and hopefully provide that next generation of avatars that can be used not just for hospitals, but also for just general work. We see so many people in this pandemic not being able to do their work because they have to be physically there. And if there's a shutdown and stay-at-home order, you're not able to go to work unless you're an essential worker now. If we can just have robots perform the kind of functions of our bodies, we can actually have people doing physical work in the crisis. So I'd like to finish off by just having a short discussion about how we can kind of think about private-public partnerships and funding opportunities and investment to sustain readiness for the next crisis. And one of the big problems in any kind of crisis situation is that we're always fighting the last war. We're also always, 3 years from now, let's assume that COVID is gone, will we forget about it? Will we forget and not be ready for the next outbreak or the next disaster? One possibility is that we can start to encourage robot stockpiles where we have, certain robotic technologies that we can predict being relevant for the next crisis available for use and deployment anywhere around the country. This is possible, but it's also rather challenging to keep up with the latest technology. As you can see that this field is changing very rapidly, and 10 years from now, who knows if everything is going to be compatible with our existing technology. So I'd like to recommend an alternative, which is that rather we should invest broadly in adaptable ecosystems of dual-use technologies. So technologies that can be used both in a crisis, but also not in a crisis. So for example, telenursing can be used for dealing with immunocompromised patients, which have to be quarantined, not to prevent them from infecting nurses, but to prevent the nurses from infecting them. Disinfection bots are also really useful for handling hospital-acquired infections like MRSA. And we really need to emphasize that we should have components that are interoperable and are robust and work all the time so that we can enable this rapid innovation in robotics, just like, for example, 3D printing and hobbyists were able to make face shields and ventilators in the early stages of COVID. And I'd like to say just the companies that I've been mentioning in this talk, V-Rotors and EarthSense, they have nothing to do with disaster response. V-Rotors is a company that works on augmented reality gaming using drones. And EarthSense is working on agricultural robots to do inspection of fields and also weeding and other kinds of agricultural tasks. So you can see that by investing in robotics as a whole, we'll be able to be more ready for that next crisis. Thanks so much. And I guess I'll pass it back to you.
Thanks, Chris. And then Matt. Let's finish it out.
Hello, everybody. My name is Matt Dunleavy, and I am the CEO and chairman of Skyscopes. I'm already on stolen time here and impinging on our question and answer, so I will breeze through here and put more than 12 pounds of potatoes in a 6-pound bag. But fundamentally speaking, my company Skyscopes is a professional drone service provider, and we are focused on bringing innovative solutions to the energy sector. As we see here in the slides, just a quick overview. I'm not going to go over the overview, but I want to show you some of the crews that we have out in California. We do drones and robotics on a day-to-day basis. We are some of the most highly certified pilots in the world. ranked consistently in the top 5 drone service providing organizations in the world. Just quick state of the industry. We thought back in 2012, 2013 timeframe that drones were going to be used mostly for agricultural purposes, which is a boon to the state of North Dakota, which is where we fly mostly because we're a big agrarian state. It was not a correct prediction. In 2015, we thought it was going to be cinematography. And now if we fast forward to 2017, this piece of the pie right here is basically the energy sector and professional services. We should expect to see some sort of sliver and then maybe some encroachment on the rest of the pie regarding COVID operations with unmanned aircraft systems. In North Dakota, we're well known for drones. I'll try not to drone on about it, but we're definitely big into our public-private partnerships. And these pictures of the partnerships really also do provide a global, I would say, scaled resiliency. Drones are a mega trend. They're used as well in storm damage assessment against disasters. Worked with FEMA before. This is a tornado. You can help speed up the insurance processes and get people affected by these disasters their insurance money faster with drones. And this is some of the work that we did with a coalition of utilities after Hurricane Florence in the East Coast. We have dismounted thermal sensors to hand them off to hospitals to help people detect elevated temperatures and people that might have COVID. And then, of course, they are perfect tools, like Professor Hauser mentioned, for social distancing. They are inherently remote sensing tools and are, able to be delivering packages in a contactless sense. And they can also be used to spray disinfectant in target locations. We do believe that the nozzles are as effective from the air as they are from other methods. We've used them on playgrounds. One of the difficult things is to be able to get the spray under, not just on the horizontal surfaces on the top, but also under. And the hurricane effect from prop wash on drones does give us confidence in the efficacy there. Other drones are off the shelf and can make drone-based disinfecting a scalable solution. And a lot of different companies are getting in the drone world new types of ways to disinfect the drones themselves. We're getting expedited waivers from the Federal Aviation Administration to fly in new ways that wouldn't have been the case without COVID hitting. We are emphasizing our public-private partnerships, working in a bunch of different federal programs, and a whole bunch of different companies across the United States are definitely in the drone world seeking to raise more venture funds. So true to form, I am going to go ahead and conclude my presentation there and open it up to questions of for which we should have about 3 minutes.
Thank you. I'll first start with something that Chris mentioned about adaptable ecosystems. So for Matt and Ryan, how would you describe kind of the first 48, I'm going to call it, after the pandemic became, a thing for us here? How did the business model shift? And what was that conversation like internally?
Yeah, I can go first. I think we had, I think the business model is evolving. It's also additive as well. It really depends on where you come from. So for example, in our industry, we're developing self-driving vehicles. It's actually easier to add deliveries if you've been focusing on moving people, right? When you develop autonomous systems for people, you need to develop not only safety, but also comfort, right? But a 6-pack of Coke and a pizza don't need the same level of comfort that you and I do when we move things autonomously. So it's very easy to kind of add that. There are some modifications you need to make to the vehicle to accept more packages and so forth, but that's on the mechanical side. That's more on the electromechanical side of the vehicle. So, and we've also piloted a prescription drug delivery almost 2 years ago as well. And the reason why we did that was we had feedback from our users saying that was actually a very useful service to be added. And so therefore we were able to add other things along the way. And as COVID hit, it struck us that, well, we got to try doing something, very, very specific for our clients that really needed us at that time. That's why we started with the meal delivery as well. So we had practice and we were prepared, but ultimately coming out of COVID, you can imagine 3 different kinds of markets. You can imagine a passenger only, a delivery only, and then some kind of hybrid where you're actually able to do both, because there's some periods of time in the day where you're not moving people, but you could be moving goods.
So first 48 hours after we realized that COVID was going to be affecting our business model was a, oh my gosh moment. Is it going to make people think that drones are a luxury and that we don't need them? So bringing a new product line in, because we usually focus on energy, to use drones to spray disinfectant in public gathering locations was a new product line that we would have launched because of COVID. And otherwise, it's, how can we make sure that our flight operations are as safe as possible? And that means making sure that we're not contributing to community spread. So we disinfect ourselves and, make sure that the pilots and the visual observers stand farther away from each other, increasing levels of autonomy with the flying, and also disinfecting the aircraft. So it's the model, it's the operations, and it's the product lines.
Great. Another question from the audience. So how is your business, your scholarship, your consumers or partners using real-time data to inform local policy, health recommendations, community or workplace activity? Anything of the like.
I would say that we've been working with the city of Boston, where we're based, and they've been gathering a lot of data on what's going on generally around COVID. One of the things that they've been very concerned about is how do you provide good access for disadvantaged groups, right? So, for example, school's out, and so the 1 hot meal per day that you would get if you're at school would be at school. If you're in session, would be at school. So, how do you provide those kind of opportunities to provide access to those groups? So we've been standing ready to assist them at any time. And certainly that's a result of the data that we've been gathering, especially because the robots that we're using, and just because they have wheels, allows us to gather tremendous amounts of data, right? Not just for improving self-driving, autonomy, but also understanding where people are. Are there people standing in front of a restaurant, for example? How many people were standing there at that location at one point in time? So I think that there is a tremendous wealth of data that you can glean for those type of analytics.
Chris, anything on your end?
Well, one thing that we've been doing is looking at some computer vision techniques and 3D vision techniques to try to map out what people are touching in real time. So we've been able to track when people are touching their faces, sort of to give them warnings about, well, early in the COVID, they told people not to touch their faces, and now the recommendations are to wear masks. But during that time, you can track what people are touching at a fine-grained level, and you can also potentially track how infection could get spread in real time. And we haven't exactly partnered with public health or built an app for that. But these AI techniques can be used in real time with potentially great effect for the future pandemic.
Matt, anything on your end?
Not really. I think these two gentlemen covered it pretty well.
Okay, great. Any sort of parting words, Ryan, Matt, Chris, Andrea, Elliot?
Thank you so much for the opportunity. It's had a good time.
That's great to see so many solutions.
Yeah, I'm excited about what everyone's working on, and I also see combinatorics here too. I can see the combination of different solutions with each other, and there's new synergies that are completely possible. I also really like the idea of the low-hanging fruit. The new terminology that I've heard is juicy fruit. So what is the low-hanging juicy fruit that we can peel and or pick up off the ground that we can utilize and challenge all of us to come up with new solutions. I'm very, very excited about that.
My only parting shot would be that when we got into drones, we frequently referenced Aldous Huxley's Brave New World, and drones are a brave new world. And with COVID hitting, it's a brave new world for everyone. But the opportunities here for social acceptance of robotics and unmanned aircraft systems themselves, I think, are something that is important to emphasize, and that panels such as this are a way to get the word out there that there are solutions that we're going to bring to the fight to take COVID out.
Perfect. I think that's an excellent note to end on, and all in the spirit of the PPP conference. So I just want to thank you all again for joining us. And if any of you viewers want to learn more about the Chamber Foundation's Tech for Good work and the Digital Empowers program, you can find us online at us.digitalempowers.org.